In our lesson for today, we'll be dealing with the real number system. Natural numbers are counting numbers. This set includes 1, 2, 3, 4, and so on. Whole numbers are counting numbers plus 0. This set includes 0, 1, 2, 3, 4, and so on. Integers are whole numbers and the negation of our whole numbers. But remember, -0 is 0. Rational numbers, also known as fractions. Any number that can be written in the form of a over b, where a and b are integers and b does not equal 0. Also includes repeating decimals and terminating decimals. Since rational numbers can be written as ratios, a ratio is a comparison of two numbers by division. -19 can be written as a ratio, -19 over 1. -1 as a ratio is -1 over 1. -4/7 is already a ratio. 0 as a ratio is 0 over 1. 2/3 is already written as a ratio. 1 can be written as a ratio, 1 over 1. When we see 17.8, we can write as a ratio over 1, but we never want to have fractions and decimals mixed. Either we want to write our numbers as decimals or just as fractions. To remove this decimal, we'll multiply the numerator and the denominator by 10. In my numerator, my decimal point will move one place to the right. This will leave me with 178 over 10. We must reduce until our numerator and our denominator are relatively prime. Since the numerator and denominator are even, we can divide by 2. This will leave me with 89 over 5. Therefore, 17.8 as a ratio would be in simplest form 89 over 5. To check this, we can simply divide. 89 over 5 means 89 divided by 5. 5 goes into 8 one time. 1 times 5 is 5. 8 minus 5 is 3. Bring down the 9. 5 goes into 39 7 times. 7 times 5 is 35. 39 minus 35 is 4. We could add a decimal point and then we could bring down a 0. 5 goes into 40 8 times. 8 times 5 is 40. 40 minus 40 is 0. And notice we have the 17.8. Remember, terminating decimals such as 0.45 and repeating decimals such as 0.777777 and so on are rational numbers. Remember, real numbers are either rational or irrational. A number cannot be both rational and irrational. In our lesson for today, we will be adding and subtracting rational numbers until we can reach a level in which we can correctly solve this problem. Our learning objective for today: reduce fractions to simplest form and add fractions with like denominators. How does knowing your math facts help in reducing fractions and finding the GCF and LCM of two numbers? Simplifying fractions means to reduce to simplest form. Numerator and denominator needs to be relatively prime. A fraction is part of a whole. Fractions with the same denominator are called like fractions. The denominator tells us how many parts the whole is divided into, and the numerator tells us how many of those parts we're dealing with. In this case, a whole is divided into 2 parts. In this case, a whole is divided into 4, and the following, a whole is divided into 6. Some fractions may look different, but are really the same as the example above. Fractions should always be expressed in simplest form. In this case, the simplest form is 1/2. When we have a fraction 8 over 12, in order to write it in simplest form, we can use the same method we use for finding the GCF and the LCM. What number divides 8 and 12 evenly? You could say 2, since 8 divided by 2 is 4 and 12 divided by 2 is 6. Does 4 and 6 have a common factor? And yes, that would be 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. Now 2 and 3 are relatively prime, and our reduced fraction is 2/3. Another way we could have did the same exact problem was simply to factor out the 4 first. And now we have our 2/3. Let's take a look at another example. 9 and 15. What number divides 9 and 15 evenly? 9 divided by 3 is 3. 15 divided by 3 is 5. 3 and 5 are relatively prime, so our reduced fraction is 3 over 5. Let's take a look at 6 over 12. What number divides 6 and 12 evenly? 2. 6 divided by 2 is 3. 12 divided by 2 is 6. What number divides 3 and 6 evenly? 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Since 1 and 2 are relatively prime, reduced fraction is 1/2. Another way of taking a look at this is to go with 3 first. 6 divided by 3 is 3, and 12 divided by 3 is 4. Now, 2 divided by 2 is 1, and 4 divided by 2 is 2. 1 and 2 are relatively prime, so our reduced fraction is 1/2. And the fastest way is to factor out the GCF, which is 6. 6 divided by 6 is 1, 12 divided by 6 is 2, and our reduced fraction is 1/2. You can always try to reduce these problems by writing it this way instead. It's the same process. 8 divided by 2 is 4, 12 divided by 2 is 6. And then 4 divided by 2 is 2, and 6 divided by 2 is 3. Or we could simply divide out the greatest common factor. 8 divided by 4 is 2, 12 divided by 4 is 3. Seventeen plus 4/9 is 17 and 4/9. 5/12 plus 1/12. Since they have the same denominator, we can add our numerators together. 5 plus 1 over 12. 5 plus 1 is 6. 6 over 12, we just reduced that. And remember, the quickest way was factoring out that GCF of 6, which is 1/2. 4/9 plus 2/9. Since the denominators are the same, we could add our numerators and write it underneath the denominator. Remember, our denominator doesn't change. 4 plus 2 is 6, and now we have 6/9. 6/9 needs to be reduced. 3 goes into 6 as well as 9 evenly. 2 and 3 are relatively prime, so our answer is 2/3. 4/15 plus 8/15. Again, our denominators are the same, so we can add our numerator and place it over the denominator of 15. 4 plus 8 is 12, so our answer is 12/15, which needs to be reduced. 3 goes into both 12 and 15 evenly. 4 and 5 are relatively prime, so our answer is 4/5. 9/16 minus 3/16. Since our denominators are the same, we can write 9 minus 3 over 16. 9 minus 3 is 6. Our answer is 6/16, but needs to be reduced. 2 can go into both 6 and 16 evenly, so our answer is 3/8. 3/10 minus 7/10. Since our denominator is the same, we can write it as 3 minus 7 all over 10. 3 minus 7 is -4, and we write that over 10. If you are having trouble subtracting integers, you can use the t-chart. Since the 3 is positive, it'll go on the positive side. The 7 is negative, so we'll put it on the negative side. So remember, we move the smaller one over and subtract. 7 minus 3 is 4, and since it's underneath the negative side, we know it's negative. -4 over 10 needs to be reduced. 2 goes into -4, -2 times 2 goes into 10, 5/10. So our answer is -2/5. We can notice a shortcut. When all the digits are repeating, we can write the decimal part over 9, 99, 999, and so on, depending on how many digits repeat. Then, if possible, reduce the fraction. When we look at 0.3 bar, we can write this as 3 over, since it's repeating after one place, 3 over 9, which is reduced to 1/3. 0.36 bar is equal to 36 over 99, since it's repeating after two digits. 0.453 bar is equal to 453. Since we're repeating after 3 decimal points, we'll write it over 999, which is equal to 91 over 333. When we look at repeating decimals, 0.2 bar is equal to 0.22 bar, which is also equal to 0.222 bar, which is also equal to 0.2222 bar. Remember, the bar means it repeats infinitely to the right. So therefore, it doesn't matter how many 2's you have, as long as the last 2 has a bar, it's going to continue forever. Let's write each repeating decimal as a fraction. Since this is repeating after 2 places, we can simply write it as 12 over 99. That's our shortcut. But we may have to reduce. In this case, we do. Divide the top and the bottom, the numerator and the denominator, by 3. This would leave us with 4 over 33. The long way would be to let x equal 0.12 bar. Since it repeats after 2 places, we'll multiply the left and the right side by 100. We'll subtract 0.12 bar from the right side and from the left, but instead of subtracting 0.12 bar from the left side, we'll subtract what's equivalent to it, which is x. When we subtract x, remember the coefficient of x is always 1. Anytime you don't have a coefficient, the coefficient is 1. There's an invisible coefficient of 1. 100x minus 1 is 99x. 12.12 bar minus 0.12 bar is 12. We'll divide both sides by 99. X is equal to 12 over 99, which is reduced to 4 over 33. Since this problem is repeating after 3 decimal places, we'll write it over 999. One of our divisibility rules is if the sum of the digits is divisible by 3 or 9, the number itself is also divisible by 3 or 9. 2 plus 3 plus 7 is 12. Since 12 is divisible by 3, 237 will also be divisible by 3. When we divide, we'll get 79 over 333. And the long way. But we don't always have all the digits repeating, so pay close attention to which digits are repeating. In this particular case, notice that only the 6 is repeating. Let x equal 0.76 bar. Instead of multiplying both sides by 100, we'll just have to multiply both sides by 10. On the left side, we're left with 10x. On the right side, we'll move the decimal point over to the right one place, leaving us with 7.6 bar. We'll subtract 0.76 bar from the right as well as the left, but remember, x is equal to 0.76 bar. When we subtract x from 10x, remember there's a coefficient of 1. 10x minus 1x is 9x. 7.6 bar is equal to 7.66 bar. The 6 bars will cancel. We'll have to borrow 1 from the 7. 16 minus 7 is 9. 6 minus 0 is 6. 6.9. Divide both sides by 9. The 9's will cancel. x is equal to 6.9 over 9. But remember, we do not want decimals and fractions to mix. We'll multiply both sides by 10. This will move the decimal to the right one place, leaving us with 69 over 90. Since 69 and 90 are both divisible by 3, this will leave us with 23 over 33. 0.76 bar is equal to 23 over 33. In this particular case, notice that only the 8 is repeating. Let x equal 5.08 bar. We'll multiply both sides by 10, leaving us 10x is equal to 50.8 bar. We'll subtract 5.08 bar from the right and the left, but what's equivalent to it? 10x minus 1x is 9x. 50.8 bar is equal to 50.88 bar. The 8 bars will cancel. 8 minus 0 is 8. 50 minus 5 is 45. We'll divide both sides by 9. X is equal to 45.8 over 9. Multiply the numerator and denominator by 10 to remove that decimal. X is equal to 458 over 90. Since the numerator and denominator are both even, I know I can divide 2. This leaves me with 229 over 45, which means 229 divided by 45. 229 divided by 45. 45, if I was thinking how many times does 45 go into it, remember, we know it's 5 because we started off with a 5. 5 times 5 is 25. 5 times 4 is 20 plus 2 is 22. When we subtract this, we're left with 4, and we write that over a divisor, 4/45. 5.08 bar is equal to 5 and 4/45. Another way of looking at this is to simply let x equal the part and not the whole portion, just the part. Multiply both sides by 10 since the 8 is the only number being repeated. 10x is equal to 0.8 bar. We'll subtract 0.08 bar from both sides. 10x minus 1x is 9x. 0.8 bar is equal to 0.88 bar. The 8 bars cancel. 0.8 minus 0.0 is 0.8. Divide both sides by 9. The 9's cancel. X is equal to 0.8 over 9. Multiply the numerator and denominator by 10 to remove the decimal. X is equal to 8 over 90. Since 8 and 90 are both even, we can divide the numerator and denominator by 2. X is equal to 45. But this is not our answer. This is just a part. We know the whole portion is 5. So please do not forget to combine the part with the whole.